You know that little bit of magic that happens every time you join a new Wi-Fi network? You find the name, you tap connect, and bam, you're online. It feels totally instant, right? But behind the scenes, there's this fascinating, super fast conversation that makes it all possible. And today, we're going to pull back the curtain on that exact conversation.
So think about it. You're at a coffee shop, you see their Wi-Fi, you hit connect. In those few seconds it takes for that little Wi-Fi icon to pop up, what is actually going on? What's the invisible handshake that lets you start scrolling? Well, it turns out it's a surprisingly elegant little chat that happens in the blink of an eye.
To really understand this conversation, we first have to meet the key players. And just like any good dialogue, this one has two main characters: the one who's asking for help and the one who's providing it. First up, you've got the DHCP Client. This is basically any device trying to get online: your phone, your laptop, your smart TV, you name it. Just think of it like a tourist in a new city who needs a street address to get around. And the one providing that address? That's the DHCP Server. This is the friendly guide, the device in charge of handing out all the unique IP addresses and making sure no two devices get the same one, because that would cause a major digital traffic jam. And here's a really cool twist you probably have in your house right now: your home router. It's actually playing both parts. To the big wide internet, it acts as a client, asking your internet provider for a single public IP address. But inside your home, it flips roles and becomes the server, managing your own private network and handing out local addresses to your laptop, your phone, all your gadgets. It's kind of like the ultimate middle manager for your home's internet.
Okay, so we've got our two players, but how do they actually talk? It's not just random shouting into the void. It's a very specific four-step process designed to make sure everything goes smoothly and without any conflicts.
This whole back and forth even has a handy little acronym: DORA. And no, not the Explorer. It stands for Discover, Offer, Request, and Acknowledge. This simple four-step dance is the foundation for how literally billions of devices connect to networks every single day. So let's break that down. It all starts with Discover. Your device basically shouts into the network, "Hello, is there a DHCP server out there that can hear me?" Then comes the Offer. Any server that hears the call replies, "Yep, I'm here and I've got an IP address you can use." Your device then makes a formal request saying, "Awesome, I'll take that one, please." And finally, the server sends back an acknowledge, which is the final confirmation. It's all yours. Here's the IP address and all the other info you'll need. And just like that, you're in. You're connected.
So the connection is made. But just like any good agreement, there are some terms and conditions. The server doesn't have an infinite supply of addresses. And this is really important: the address your device gets isn't its to keep forever.
First, let's talk about the supply. A server can't just make up addresses out of thin air. It has a specific, predefined range it can work with, and that's known as an IP address pool, or sometimes a scope. Think of it as its library of available addresses that it's allowed to lend out. And network administrators have a ton of control over this pool. They can set the start and end of the address range. They can also create exclusion ranges, which are like putting up do not disturb signs on certain addresses, perfect for things like servers or printers that need a permanent, unchanging address. They can even make reservations, which is like putting a specific address on permanent hold for a specific device, so it gets the very same one every single time it connects. And this brings us to a really crucial idea. When your device gets an IP address, it doesn't own it forever. It's not a deed to a house, it's a DHCP lease. Your device is basically just renting the IP address for a set amount of time. This whole concept of a temporary lease is the absolute key to keeping networks efficient and organized.
Right? So this whole renting idea means there's a ticking clock. The length of that lease time has a huge impact on how the network performs. And there's a whole automated process built around what happens as that clock starts to wind down.
So here's what that life cycle looks like. When the lease begins, a countdown timer starts. Once it hits the 50% mark, your device quietly pings the server and asks, "Hey, just checking in, can I renew my lease?" It's all very polite and automatic. If it doesn't hear back, it'll try again. But once that timer hits the 87.5% mark, it starts to get a little antsy. It starts broadcasting to any server out there, shouting, "Help, I really need to renew my lease." If the clock runs out completely, well, the device gets evicted. It has to give up its IP address and start that whole DORA dance from scratch. This all begs a really important question for anyone managing a network. Should you set a short lease time or a long one? As it turns out, there are some pretty big trade-offs either way.
Yeah, picking the right lease time is a real balancing act. Short leases, they're fantastic for recycling IP addresses quickly. Think of a busy coffee shop or an airport. You want those addresses freed up as soon as someone leaves. The downside? It creates more background network chatter from all those constant renewal requests. Long leases are the total opposite. They keep the network quiet, but you risk running out of addresses because devices might hold on to them long after they're gone. This is great for a stable office network where the same desktop computers connect day in and day out.
So, after all these details, clients, servers, leases, this whole DORA dance, let's zoom back out to the big question. Why? Why bother with all this complexity? The answer really comes down to one incredibly powerful word: automation. Just try to imagine a world without DHCP. A network admin would have to walk over and manually type an IP address into every single phone, every laptop, every printer. It would be an absolute nightmare of typos and conflicts. DHCP automates all of that. It gives you centralized control. It saves countless hours of tedious work. It makes it possible for huge networks to even exist. And ultimately, it's the reason we can all just tap connect and have it, well, just work. And this isn't just some nice-to-have feature. It's an absolute necessity. The automation that DHCP provides is what makes modern network management even possible. Without it, the manual work would be completely overwhelming. So the next time you connect to a network, just take a second to appreciate that silent, invisible conversation that's happening for you. It really makes you wonder, what would our digital lives even look like without this process, working tirelessly in the background billions of times a day just to make sure we can all get online?